Okay, let's talk a little bit about density. Density is a physical property that's pretty commonly measured or utilized to understand information about samples. Uh, so it's important that you know how to quantify density, how to utilize it for quantifying other things. So you need to know what density is. It's just a ratio of a sample's mass to its volume, okay? So you can think of it as an equation if you want. And so D equals M over V, where D is the density, M is the mass, and V is the volume, okay? So you could go in the lab, you could take a sample, you could measure its mass and measure its volume and divide those two values, and it would give you the density. Or alternatively, you could, just measure the mass or just measure the volume of the sample. And if you know what that sample is, you can typically look up its density and utilize it to calculate the other thing. Okay. So if it's more convenient for you to measure mass, you could just measure the mass and use the density that you find in the table for that substance to calculate volume. Or if it's more convenient for you to measure the volume of that substance, you could measure the volume and look up the density and calculate mass. Okay, so you can utilize that equation to solve for any of those three parameters. Okay. So the key is all three of those physical properties, density, mass, and volume, they're all tied together. They all are linked, okay? So if you know two of them, you can calculate the third, okay? Now, also with these calculations, what you have to realize is density doesn't have some really new unit. Okay, so it's really a combination of the physical properties of mass and volume. So the unit of density is just a derivation from those. Okay, so it's a combined unit. Okay, it has a combined mass per volume unit. So the unit of density that you get by calculating mass divided by volume depends on what unit you plugged in for mass and what unit you plugged in for volume. Okay, so you can come out with units of, say, grams per milliliter if you plugged in mass in grams and volume in milliliters. Okay, or you can come out in units of grams per cubic centimeter, kilograms per liter, etc. Okay, now when you look up densities, that density would be given with a unit. Okay, and if you're talking about liquids, most of the time they use the unit of grams per milliliter, and solids, they usually use the unit of grams per cubic centimeter, and for gases, they use something more like grams per liter, which I don't even have on this list. And so it just kind of depends on where you get the value or how you did your measurements on what units you're going to end up with, but you can always convert between them. Okay, if you have a density in grams per milliliter, but you want it in kilograms per liter, you can do those conversions. Okay, just by using dimensional analysis and unit relationships. Now, a couple other important things to realize about density is density is what we would call an intensive property. And an intensive property is something that doesn't depend on how much you have, okay? As opposed to, which I don't have listed here, but this is as opposed to an extensive property. So an intensive property is the opposite. An extensive property depends on amount, okay? And so this is for other things. There are some things that are extensive, there's some things that are intensive. And so properties are one or the other. Okay, so density specifically is an intensive property, meaning it doesn't matter how much of a sample you analyze. If you analyze a small portion of a sample, and then you analyze a large portion of the same sample, they're going to have the same density, okay? Because it's the same substance, okay? If you have a different substance, it's going to have a different density. But if you just change the amount, you just decide to use a bigger sample of this, it's going to have the same density. Whereas there's a lot of other properties that are actually extensive. So specifically, the other two things you use to calculate density are extensive. So mass and volume, okay? So extensive, that would include things like mass and volume, okay? If you take this, you have this large sample and you weigh its mass, it's going to have a large mass. But if you just take a small portion of that and weigh the mass, it's going to have a smaller mass because it's only part of it. Okay. Same with the volume. The volume of the big sample is large. If you just take a small amount of that, it's going to have a smaller volume. Okay. So mass and volume are things that are extensive. They depend on how much you have, whereas density is intensive. Another common intensive property you measure in like a chemistry lab is temperature. Okay, the temperature of a sample, it doesn't matter if you take the entire sample or you just take a small sample of it and go measure the temperature. The temperature doesn't change unless if you do something to it. Okay. So that's just, an important concept. The reason that we talk about density being an intensive property and it doesn't depend on the amount, and why that would be important is because then it helps you, at least some of the times, identify what you have, or at least narrow down the possibilities. Because if something like water has a density, at least at 4 degrees C, it has a density of 1 gram per milliliter, okay? And so if I have a sample and I measure its density and it's significantly far off from that, then it's definitely not water, okay? And so your density is kind of an identifying characteristic of a substance, okay? So that's important to know. Sometimes that's a useful tool in lab. Now, one other thing that I already kind of mentioned a little bit, it is specific to the identity of the substance, but also to the phase, okay? So water has a density of 1 gram per milliliter. When it's in the liquid phase, it's pretty close to that, no matter the temperature, okay? But if I take that sample of water and I freeze it, the density is going to be different, okay? Most substances, when you go from a liquid to a solid state, the density goes down. The density goes up. Water is the unusual one, the density goes down when it goes to the solid phase. It's a little unusual characteristic, but the key to remember is if I have a different substance, I have a different density. If I have the same substance in a different phase, I also have a different density, okay? And the reason that the phase changes the density is because pressure and temperature changes affect kind of the arrangement of molecules, how much they space out, and so that will affect the density, okay? And the identity of the substance, I probably should have listed that as well, but the identity, the reason that changes it is because how the different molecules interact with one another. So an H2O molecule interacts with other H2O molecules in a certain way, which results in a specific density, a certain arrangement of things. Whereas if I have a sample of, say, carbon dioxide, CO2, those CO2 molecules interact with one another in a totally different way, and so it causes a totally different arrangement, and so a different density, okay? So those are kind of some key points about what is density and what you should understand about density. Now, let's look at a few calculations involving density. So first, I say we have a chemist who's trying to identify an unknown liquid. And they find that 25.00 cubic centimeters of that substance has a mass of 19.625 grams at 20 degrees C. Okay, and I want to know what's the density of that unknown liquid. So kind of the key is, let's think about, what information do we have? What are we looking for? And so we have, a volume, right? We have this 25 cubic centimeters. That's a volume. Okay, so that's V. I'm just going to write that down. And then we have the mass, right? And so we have M, that's 19.625 grams. We also have 20 degrees C, it's temperature. Okay. It's helpful to just pull the numbers out of the problem. Sometimes it helps you see things a little bit better. Sometimes they're all useful, sometimes they're not. And then we want to know the density. And so it's helpful to know that density is mass over volume. And so then that leads us to how we're going to solve this problem. We're looking for density. We have the mass and volume, right? We want to plug those into that equation. And so my density in this case, oops. Sorry, this is erasing my work on me. Density in this case is going to have to be, here we go, maybe. We'll act like there's an equal sign there. So my density is my mass, which is the 19.625 grams over 25.00 centimeters cubed. Again, this is supposed to be an equal sign. There we go. Now it's working. And then we just need to punch it in the calculator. 19.625 divided by 25.00, that gives me 0.785. That's what the calculator tells me, okay? So again, always pay attention. This is what the calculator gives us. Now, don't stop there. Always go back and analyze sig figs, okay? So look at this value, that's 5 sig figs, okay? And this value, that's 4 sig figs. And I'm doing a division, so I'm looking for fewest sig figs, okay? So 4. So in the end, I need 4. This 0 does not count, okay? So I have the 7, the 8, the 5. I'm only reporting right now 3 sig figs. That's not good. I need to report 4 sig figs. So really what I should be reporting is 0.7850, okay? I know that a lot of people don't like doing that. That is the proper answer. And so it is actually known to that 4th sig fig based on the measurements. Okay, so that would be my answer. Okay, so that's just easy plug and chug. Plug into this equation the values you have and solve for the thing you don't have. Okay, now let's look at using density in a little different way. Okay, so here I say to use the density of iron, which is 7.87 grams per cubic centimeter, as a conversion factor to answer the following questions. Okay, now just kind of a heads up. If you ever are trying to do calculations and you realize, you know what, a density is missing. I need this density to do this calculation. Most of the time you can look up the density, okay? In chemistry, usually there's tables of densities in your textbook, and that's where you want to go if it's not given. But here I gave it to you, okay? And I say to use it as a conversion factor, or I could say as a unit factor, if that helps. And so we're going to use it as a conversion factor or unit factor, meaning we're going to do dimensional analysis using density, okay, instead of relying on this equation to do these calculations. So the first one, I ask for the volume of an 8.533 gram sample of iron, okay? So if we're going to do this with dimensional analysis, I'm going to write down the value I have, which is 8.533 grams, and I'm going to focus on units, okay? So if it helps, you can write that over 1. You want to get rid of grams, right? And you want a volume. And so we want a volume unit, and we're going to utilize density as our conversion factor. So I can convert between grams and cubic centimeters, okay, which would give me a volume. And so that, writing down those units first, that's forcing me to set up my calculation properly. Okay, so my grams are going to cancel and give me a proper volume unit. Okay, so then I just take that density and I plug it in. So this density tells me it's 7.87 grams. So I'm going to put the 7.87 grams with the grams, and then that's per 1 cubic centimeter. Okay, and so that is going to cancel my gram unit and give me cubic centimeters. And so then I don't even have to think about it. I just, plug it into the calculator based on what dimensional analysis is forcing me to do. So 8.533 divided by 7.87, and that gives me 1.084243964. That's what the calculator tells me. Okay, calculators don't know sig figs, guys. Okay, so again, we got to go back, analyze sig figs. So here, this is 4 sig figs. Okay, and densities, guys, even though that was a given value, some people want to say, well, you gave me that density, that must be exactly, that's right. No, that's a measured value. Someone had to do an experiment to figure that out. And so that has error. And so that's 3 sig figs. Okay, so 4 sig fig value, 3 sig fig value, 3 sig figs limits my calculation. So I have a 1, a 0, an 8. Those are my 3 sig figs. I look to the right of that. The 4 isn't going to affect it. So I have 1.08 cubic centimeters as my answer, okay, for my volume. Now, next one, I want to know the mass of a 28.6 cubic centimeter sample of iron. So 28.6 cubic centimeters, okay, which is a volume. And I want to convert that volume to a mass. So I'm going to set it up like dimensional analysis, okay, because I want to use that density as a conversion factor. Then, so that's basically on the top, right? So I'm going to multiply, I'm going to put centimeters cubed opposite to cancel. And then I want a mass unit. And based on the given conversion factor, I'm going to be going to grams. Okay, sure, you can convert that grams to some other unit, but you don't need to. Okay, because I didn't ask you to. And then I just pull that information. It's 7.87 grams per 1 cubic centimeter. And so that is set up to where it will cancel my cubic centimeters and it will give me grams. And so then I don't even have to really think about it. I just plug that into the calculator now. If you do your unit analysis right to start with, that solves the problem for you. So 28.6 times 7.87, that gives me, at least the calculator tells me, 225.082 grams. But as I keep saying, the calculator, doesn't know sig figs. Don't just give that as the answer. So pay attention to your calculation. You have 3 sig figs here, 3 sig figs here. And so 3 is your lowest. Both of them are 3 sig figs, so you round your answer to that. So the 2, and the 5. Those are my 3 sig figs. Look to the right, I have 0, so it does not affect the answer. So I have 225 grams is what I would report so that it is to the appropriate number of significant figures. Okay, so that is, how you can keep doing dimensional analysis using density. So instead of using the density equation. Now you can solve these problems using D equals M over V. That is perfectly fine. okay? But the reason I show you doing dimensional analysis is that that is so useful for chemistry, okay? Most problems, when you get kind of stuck, if you can fall back on just following units, it'll lead the way, okay? So this is just a really useful way to tackle things with density because it applies to other things as well, okay?